All right, folks. Just want to go over a few problems on your benchmark for review, which, as you know, is very similar to the actual benchmark. So this is a pretty good study opportunity. Okay, so let's take a look at number one. So what value of x makes lines R and S parallel? Okay, um, so we want R and S to be parallel, and we have a transversal right here. So the easiest thing to do without thinking, oh, hey, these are alternate exterior, is just do dot squiggle. Okay, remember our pattern here. So our pattern is dot, squiggle, squiggle, dot, dot, squiggle, squiggle, dot. Okay, these are both dots, so we know that they should be equal to each other if R and S are parallel. So let's set them equal to each other, and let's solve for x. Okay, this is an Algebra 1 problem. Should be a piece of cake. We'll subtract 14 from both sides. Okay, let's see. 143 minus 14 comes out to 129. Of course, you can use your calculator if you're not so sure. To get the x by itself, we undo times 3 by dividing. 3's cancel. We get x equals 43 degrees. And that's it for number 1. Okay, we're going to go down this way. Take a look at number 3. So number 3 says if PQ is parallel to WK, what is the value of x? So if PQ is parallel to WK, that means that both of these diagonal lines are transversals. So we can do dot squiggle with either one. Um, let's do it with this one. So we'll do dot squiggle squiggle dot. Okay. Um, so according to dot squiggle, this 52 degrees should also appear up here. Okay, these are alternate interior angles. So this should be 52 degrees. Okay, so this is 52, this is 60, this is x. We have a triangle. What do those add up to? They add up to 180. So we can do x is equal to, and we'll just subtract the stuff we know from 180. And we end up with, let's see, x equals 180 minus 112, or x equals 68 degrees. And that's it. Okay. Could you set up an equation with x plus 52 plus 60 equals 180? Yes, that's totally fine, and you're going to get to the same answer. Okay, moving on. Mr. Ammons is constructing a walkway through his rectangular garden. Okay, his rectangular garden. The walkway runs diagonally, as shown. What is the length of the walkway? So we need to find the length of the walkway, and we know that this is a rectangle. Okay, well, if this is a rectangle, that means that these angles are 90 degrees, they're right angles, right? Okay, and so what we have here is a right triangle. We also know that because this is a rectangle, that this top side is 24, and this left side would be 15. Okay, so we just have pick which one you want to work with. We have a right triangle, and we need to find the length of the hypotenuse. Okay, so we're going to have to use our lovely Pythagorean theorem. A squared plus b squared equals c squared, where c is the hypotenuse, a and b are the legs. Let's go ahead, we'll put 15 for a, so 15 squared plus 24 squared equals c squared, and go ahead and punch these into your calculator, simplify. We get 225 plus 576 is equal to c squared. or 801 equals c squared. Okay. To undo a square, remember you take the square root of both sides. So we get the square root of 801 is equal to c. Okay, and we can make a factor tree and try to pare this down and maybe find some perfect squares to pull out, but um, just to save a little time, we'll go ahead and just punch it in the calculator and find the decimal. Okay, so let's see, let's type this in. And our decimal comes out to approximately 28.3 feet is approximately C. Okay, let's switch over to a different color for the right side. Let's do blue. That's pretty good contrast. Oh yeah. All right, find the value of x. We're given a right triangle. This looks like maybe we have two poles in the ground with a wire coming down. It doesn't really matter the scenario, but hey, that's what it looks like. Okay, so we have to find x. So we have a triangle. We're given an angle. We're given the hypotenuse. And we're given one of the sides. Okay, now this would be the adjacent side because it is touching. That 20-degree angle is formed by the hypotenuse and that leg. So this will be our opposite side. Okay, O. So let's go ahead, think about SOHCAHTOA. SOHCAHTOA. And looking at what we're given, it looks like we're going to have to use cosine because we're given h and a is a part of our problem as well. Okay, so let's set this up now. Remember the setup for cosine is cosine of theta, your angle, is equal to adjacent over hypotenuse. So cosine of 20 degrees, let's make sure our calculators are in degrees, people, is equal to x over 80. And, just to give ourselves a little bit of comfort here, we'll put this over 1. Okay, why not? So if we want to solve for x, we have to undo x divided by 80. So how do we do that? We're going to multiply by 80 on both sides. Okay, multiplication undoes division. So these cancel, and we get 80 times cosine of 20 is equal to x. Okay, now remember our calculator has to be in degree mode. Okay, make sure we're in degree mode here. And let's go ahead, we'll punch this in the calculator real quick. 80 times cosine of 20. It's about 75.1. Let's see, our units are feet, is equal to x. Okay, and the challenge in this problem is identifying which trig function to use. Okay, if you identify the correct trig function from there, it's a little bit of algebra, no big deal. Okay, so we have a parallelogram ABCD is a rhombus. What is the measure of angle DAE? So we need to find DAE. We need to find this little guy right here. So there are a couple pieces of information that are going to be really helpful. Okay, really helpful to us when it comes to dealing with rhombi. One is that our diagonals, so our diagonals are perpendicular. Okay, they're perpendicular, so they intersect at right angles, right? And what's another piece of information that is going to help us out? Not only are they diagonal, but they also bisect your, I'm sorry, not only are they perpendicular, your diagonals bisect opposite angles. Okay, your diagonals bisect opposite angles. So if this is 36, since this angle is being bisected, the other side must be 36 as well. Okay, and we'll have 36's down here. Okay, this is a right angle. Right? So what it comes down to is, well, we have a little triangle here, and we're just missing one of the angles. So we can do 180 minus 90 for the right angle, minus 36 for the angle that we know, and whatever's left, well, that will be angle DAE. Okay, so 180 minus 90, well, that's 90 minus 36. 90 minus 36, what does that come out to? It's, what, 54? 54 degrees is equal to the measure of angle DAE. Okay, again, the properties that helped us out were the fact that diagonals are perpendicular, so that lets us fill in a missing angle here, and the fact that they bisect opposite angles. Okay, they bisect opposite angles, so we know this is 36, 36. Okay, we could have found this side as well. That would have given us the same thing. Moving on, number 7. A rectangular rug is 24 feet long and 10 feet wide. A rhombus design is formed inside the rug by joining the midpoints each side of the rectangle. Well, we're not given a picture here, and it really looks like we need a picture to help with this problem. So let's go ahead, we'll break this up a bit, and let's draw a picture. So we know that we have a rectangular rug, so let's make this a rectangle. Okay, let's assume this is straight enough, right? Here's our rectangle. Okay, and then a rhombus design, so we have a rhombus that's formed inside the rug by joining the midpoints. Okay, so right about in the middle of each side, we join the midpoints of each side of the rectangle. So we'll go ahead and make our rhombus here, and even on my terribly drawn rectangle, this rhombus looks almost like almost equilateral. Okay, the sides look just about the same. Okay, so because it's a rhombus, we know that the side lengths are the same. Okay, so if we find any one side of this rhombus, we have found all of them. Okay, let's see, what are some useful pieces of information? Oh, well, the rug is 24 feet long, so if the entire length is 24, then one of the segments on the length, one of the half segments would be 12. And if it's 10 feet wide, then one of the half segments on the width would be half of 10 or 5. Okay, let's see, the other piece of information that will help is that rectangles have all right angles. They have all right angles. So this corner is a right angle, 90 degrees, and we look, it's pretty easy to spot. Boom, there's our right triangle. Okay, there's our right triangle. So we have the legs, we have the hypotenuse here, we'll call it C, and we'll use our lovely Pythagorean theorem, a squared plus b squared equals c squared. Let's plug 5 and 12 in for the legs. 5 squared plus 12 squared equals c squared. Solve for c. So we have 25 plus 144. we get 169 equals c squared. Take the square root of both sides, square root of 169 equals c. And if we pop this in the calculator real quick, a lot of you guys should know this one. This is a one you're supposed to have memorized, but anyway, the square root of 169 is exactly 13. So our answer for this question would be 13. 13 feet, I suppose we should clarify. Okay, I have a couple more for you, so we're just going to scroll down. So if you haven't gotten these copied down, take a moment to pause the video and just make sure your answers are correct. And we're going to scroll down. Okay. So here's two problems. We'll start with 16 and then do 17. Okay, let's do lovely pinkish color. All right, so find angle GCF. So we have to find this angle. Okay, and all that we're given is, I suppose this is a parallelogram. So we can mark it as such. So we have a parallelogram. Okay. And we have a right triangle tacked onto the side. And we're given one of the angle measurements in the right triangle is 40 degrees. So let's see. A couple facts about parallelograms. We know that opposite angles are congruent. So if we find this angle DAB, that's the same as finding GCF. Okay, that'll help us out. And we have a straight line here, so we know that these two angles, let's mark this in another color, these two angles form a linear pair. They add to 180. Okay, so our plan of attack is to find this angle that I marked in green, subtract from 180, and that'll give us our angle that we're looking for. Okay, so here's our triangle. We know that these angles should add up to 180. So if we're looking for our little missing angle here, we can do 180 minus 90 for the right angle, minus 40 for the angle that we're given. Whatever's left will be our little green angle here. So 180 minus 90 minus 40 comes out to 50 degrees. Okay, so this is 50 degrees. All right. And again, we'll subtract from 180 one more time to find the angle that forms a linear pair with this. 180 minus 50, we get 130 degrees. Okay, so our angle DAB is 130, and because the opposite angles are congruent, that is our angle GCF. All right, last one. So here we're given two triangles, and we want to know what values for x and y make them congruent. Okay. Triangle MNO congruent to PRT. So what's going to help us here is our CPC TC, corresponding parts of congruent triangles are congruent. Okay, so what that means is if we line up the letters, okay, in our congruent statement, that tells us what angles are congruent to each other and what sides are congruent to each other. So we know that MN must be congruent to PR. Well, we have a measurement for MN and we have a measurement for PR. So we know that MN is congruent to PR. So 3x minus 9, we can set them equal, is equal to 24. Let's go ahead, solve for x. We undo the minus 9 first, so we'll add 9 to both sides. So we get 3x equals 33. Undo times 3, we'll divide by 3. We get x equals 11. So one of our answers, we get x equals 11. Okay. Now let's find y. Well, let's see, we have a 3y here, and this is angle t. This is angle t. Let's do that in a different color. This is angle t. So by our little CPC TC, that means angle T and angle O have to be congruent. So here's our angle O. Oh, this is easy. Let's set them equal to each other. So we know that angle O is congruent to angle T. So 82.8 degrees is equal to 3y degrees. And let's go ahead, solve for y. Divide by 3. Now, is this going to give us a nice number? No, it'll give us a decimal, and that's okay. So these cancel. 82.8 divided by 3, pop that in your calculator, and you get y is equal to 27.6 degrees. So these are the two measurements that we need in order to ensure these two triangles are congruent.